So today we're looking at a difference between what's called Euclidean geometry and spherical geometry. Euclidean geometry is what we've been studying all year. So Euclidean geometry is sometimes called plane geometry, or it's in space. Spherical geometry, however, is geometry on a sphere. And this gets a little, I don't know, you can kind of overthink some of this stuff maybe, and it gets kind of weird in your head. At least that's how I feel sometimes about it. When we're looking at plane geometry, this is all you've ever done. Okay? When you were in first grade and your teacher talked about lines and the way lines look and how we define things or how points are defined, we're talking about it being on a plane. If you're talking about things being on a sphere and they're like contained within that sphere, would you have an actual line the way we think of lines being? No, if you think about a line being something straight, you wouldn't have that on a sphere, correct? It would have to kind of like curve around. So some of our definitions are going to look a little different. Or if you think about maybe like what a triangle might look like. If you guys can envision, I should have brought a balloon, I didn't think about it this morning. If you can envision like not having a balloon inflated and drawing a triangle on it with like a permanent marker and then inflating that balloon, would that triangle still look like a triangle? Not really. It would kind of look more like this, correct? If it were on that sphere. If you drew it on, like the plain flat surface and then inflated it, it wouldn't still look like that triangle the way we're used to seeing it. So one thing we're going to look at for this, we're not going to have a chance to like go super in depth with everything in spherical geometry. This is just meant to be a little bit of an overview. But it says here, like for the spherical geometry, sphere E contains great circle M. So this is the great circle M, and point P that's not on M. Maybe underline this. The great circle is what's considered a line in spherical geometry. Because that would, continue to go straight, but it would have to kind of like curve around that sphere. So a line in spherical geometry is the great circle. So when we're describing some of these following things, this first one says, describe two lines containing point P. So point P is this point right here. This point is contained within this great circle. So I need to name that great circle. When I name it, I just include 2 points on that. So I could call it PQ or HL or any combination of those 4 points. So I would name this, maybe let's say line, QP. So line QP. And another one that contains that point would be this great circle here. And maybe I want to call that one PK. You would just pick any 2 points on that line or that great circle, and that would be how you name it. For the next one, a segment containing point Q. So here's point Q. A segment would just be like part of that line. So you might say like QH would be considered a segment of that line. Or you could say like QR. You want to maybe give yourself a couple examples or just give yourself one. I'm going to say HQ and just name it as a segment. And then in this one here, this triangle, we just want to name any triangle. Let's go with triangle S, Q, P. So S, Q, P. So just kind of getting some of these definitions onto the sphere. Okay, for these pictures here, we have to decide whether this is a line in spherical geometry. So in order for it to be a line, it has to be part of the great circle, or the circle that goes through like the biggest part of the sphere. So for this example, is P a line on that sphere? Yeah. What about M? Would M be a line on that sphere? No, because it's not the great circle. Okay, it's too far up on the sphere. It'd have to be.
It has to be a great circle in order for it to be a line.
Yes. Can't just be any circle. It has to be like the biggest one through the poles that we talked about yesterday. Okay, or what about for this basketball? Would this be considered a line on that sphere? No. How many lines would be on that basketball? 2. You'd have like this one here or that one there that are at least drawn in. You could have an infinite number, you know, if you just drew them in yourself. Beat you to the punch. Okay, sometimes what we can do is we can compare postulates between Euclidean and spherical geometry. So the directions would say something like, tell whether the following postulate or property of plane geometry has a corresponding statement in spherical geometry. If so, write the corresponding statement. If not, explain your reasoning. So this first one says, any 2 distinct lines, so I'm going to go ahead and just change that now. Instead of lines in spherical geometry, that would be great circles. Are parallel or intersect once. So in spherical geometry, are the great circles parallel or intersecting once?
Wouldn't they intersect twice?
They would intersect twice. Does that make sense? Let me get a ball.
So let me show you here why, if you have 2 great circles, this is really bumpy, so I'll just try to draw that in. If I have 2 great circles going around the center, hopefully you can tell that these great circles aren't just going to intersect once, they're actually going to intersect twice when you get around to that other side.
That are parallel. So I'm going to rewrite this. A corresponding statement would say any 2 great circles intersect. Oops, I didn't spell sect right. Intersect twice. So you can go ahead and change that on your note-taking guide too. The second one says a line segment is the shortest path between 2 points. So what do you think about that? Would a line segment be the shortest distance between any 2 points? If you have 2 points on the sphere, would a line segment be the shortest distance between those?
The shortest distance, like going through the circle?
Potentially. But I think for this right here, what it's meaning is like everything's on, this is geometry on the sphere, not like necessarily like through the middle. So I see your point there. Okay? The only thing I would change maybe here is instead of saying the line segment, what would the line segment look like on the sphere? It'd be curved, and that would be called an arc. So maybe like an arc is the shortest path between 2 points. Man, I really kind of messed up here on the spelling, didn't I?